Hello, good afternoon, everyone. Thank you so much for taking out time to attend this session. We are really glad and happy that you have taken part and by registering for this hackathon in order to help you, build these apps. We have conducted these workshops, and happy to have you here. Still have people who are joining in, so we'll just getting started in a moment. In the meanwhile, a couple of housekeeping announcements. This session is going being recorded. We will be we will be uploading this presentation on the campaign website. Should you need to refer it at a later stage, you please to go to the campaign website and you can play the recording. And one more thing is that we have kept you on listen only mode during the entire course of the session. We will be opening it up to for a quick Q&A session at the end of the session. So, and we'll be happy to take your questions. In the meantime, if you have any questions, please feel free to type in your questions in the chat box, and we'll try and get the answers for your questions. And today's session is weekly on will be basically on Google Cloud Vertex platform. So, and we would be handing over the stage now to Vipin Nair to take you through the session and a couple of demos which he's got. With no further delay, I'll hand over the stage to Vipin Nair. Vipin, over to you. Thank you.
Yeah, thanks, Avinash, and welcome everyone. Thanks a lot for joining this session. And what we'll be doing today in the next about an hour or so is I'll walk you through some of the Google Cloud's AI ML capabilities. There are a few slides, and then we can also look at maybe the actual console of the Vertex platform. While I'm doing so, feel free to type in your questions on the chat window of this Google Meet console. And as I see these questions, I'll try responding to them during the presentation itself so that it is interactive. But if you have questions that you want to hold on till the end, then we can also, if time permits, have a Q&A towards the end. But yeah, feel free to just keep entering your questions as and when you think of those. All right. So with that, let us get started. So I just as a quick introduction about myself. So I'm Vipin Nair. I have about 21 years of experience in the industry. I am currently with Google, and I am the ML specialist. And I help Google clients onboard, evaluate, and also implement ML use cases on the Google AI ML stack. So with that, let's quickly get started. So what you see on this slide is the whole spectrum of the various activities that we would have to do as part of building the data fabric for any application or use case that you are implementing. So there are things that or there are data sources which you will have on your leftmost side, and these could include your corporate systems, third-party systems like weather data that you're looking at. It could also include sales information. It could include any of your hosted applications. It could include sensors that you have deployed as part of your use case or enterprise application. You may be scanning social media if it is for brand and marketing, and then you can also look at geospatial information. So there are a lot of wide variety of data sources. It usually starts with collecting of these data sources, and these data can be in the form of either streaming data, or they could come in terms of bulk transfer, and we have a lot of tools towards helping you collect the data, and that is one of the important data engineering aspects. Now, once the data is collected, then you would want to process the data. And in order to process the data, or what we mean by process the data is you may want to aggregate it, you may want to derive features out of it, you may want to maybe break, for example, a date field into sub elements. You may want to move up uh, data coming from IoT devices, which are at a second level, to maybe at an hourly level aggregations or averages, because that is what makes sense for specific use cases. So all those things are part of your process activity. And you have tools like data flow or data proc and data fusion on the Google platform to combine or do this aggregation at scale. There are orchestration components like Composer that allow you to orchestrate this whole data engineering or processing across these various components, right? So that's the process part of it. Now, to do anything with the data, you will have to collect the data, process the data, and then you will have to store it in some amount, some kind of data sources. And this storage is of two types. One is to support your immediate use, transactional use, which is consumed directly by your applications. And this could be like sales transaction, this could be credit card transaction, this could be your point of sales information that is being scanned. So all those things are usually also stored for immediate consumption and immediate logging. Uh, and so this is predominantly transactional. And then you would also, over a period of time, want to analyze the data or all the activity that has been happening as part of your entire pipeline, which is where you would have something like a data warehouse. In our case, it would be BigQuery, where you will start storing all this information at scale, so that then you can use all this information from your warehouse that you have been collecting over the last few months, weeks, years, and then start building out reports using Looker or any of those BI tools, or building out AI ML models using the AI platform. And this is where you get most of your insights, and this is where you get most of your inference capabilities. For the data that you have been collecting over time. So this is where you will try to understand what are your behavioral patterns, and then based on those insights, you will start making decisions, or you will start building out rules, or you will also start seeing ways in which you can monetize all the data that you have collected. So this is essentially the whole end-to-end pipeline of how the data travels right from your data sources all the way up to how it starts influencing decisions, or how it can start showing up in some sort of an intelligent way, maybe recommendations as well, right? So that's a quick overview of the overall integrated data platform. And if you're looking at platform providers like Google, there would be elements at each and every phase for all these different activities. So for collection, you will have data transfer services, you will have PubSub. For processing, you will have data flow, data proc. For orchestration, you will have things like Composer. So all these are like platform components. For storage, you will have Cloud SQL, you will have Spanner. And for warehousing, you have all the platforms like BigQuery, Cloud Storage, and for AI ML, you will have platforms like Vertex AI and API. So all of these different cloud providers would have components supporting each of these different uh, stages. Right? So now let's quickly move to the next slide, and this is where we will start or double click into the AI ML capabilities that you have on the Google stack, which is the topic of discussion today. Now, when it comes to AI ML, there are uh, different layers of AI that you can infuse into your applications. I'm sorry. There are different layers of AI that you can infuse into your application. So, yeah. So at a very high level, without having to know anything about machine learning, or without having to know anything about data science, without having to write any TensorFlow or scikit-learn or PyTorch kind of code, you can still infuse AI into your applications using some of the APIs that are available directly on Google Cloud. So there are APIs like Vision API, whereby you can upload an image and you will get data describing those images. There are video intelligence APIs, natural language APIs. So all these are APIs that are exposed on Google Cloud. You can make a function call to those APIs and you get back the result. You don't have to write a single model or any ML kind of code. It is just that you provide your data and you get the output or inference. Underneath those APIs is a model that Google has been hosting, and this model is trained over the years by collecting data across a lot of different sources. For example, natural language would have collected data from Wikipedia, news, a lot of public information blogs, etc., that is available. Vision would have been collected by crawling a lot of images over the years from different sources and being manually labeled by Google Workforce. So we have built these models, and we have hosted these models for you to consume via a single API call. This will not be specific to your use case, but this will give you enough generic information, like, for example, translation. It will give you a good, decent translation from one language to the other. But if there are domain specific words that come into picture, and your domain is very niche, then that will not be supported. But as long as you keep it in the generic realm, you can use these APIs and you can still have some AI ML capabilities built into your application. Those ML capabilities are ML models built by Google, hosted as APIs. Now, let's say you want to build something more complicated. You have your own data, you have it labeled. So you have maybe a set of images and you have labeled it depending on how your use case is, right? So if it's a medical use case, for example, you have a set of X-rays and you have labeled those X-rays, and now you want to build a model out of it. Or if it is a set of feedback that you have collected and you have labeled the feedback into different categories and you want to build a model to now classify all the feedback that you are getting. So in this case, what you have in hand is a set of labeled data. Now, let's say you don't want to write your own ML code. You either don't have the time or you don't have the expertise, in which case we have something called AutoML models or AutoML custom models. What it will do is it will allow you to upload your labeled data, and the platform will build a complex model for you trained on your specific data, right? And then that model is available for you to consume, in which case what has now happened is all your uh, domain specific and custom or your proprietary data trained model is now available for you to use. If you want to go down one more level, then what we also offer is the ability to build your own ML model. So you have, in this case, your own data, and you have the expertise to build AI ML models. You have data scientists, or you know TensorFlow, you know PyTorch, and you want to build your own model. In that case, we provide a platform which includes right from development ID, notebooks kind of capabilities, all the way to automatic one-click deployment of your model. So we provide all that in one single platform, which is the Vertex AI platform. And that kind of neatly integrates with a lot of the other data pipeline components like data proc, data flow, data warehousing in BigQuery. So this AI ML platform, which you will use to build your own specific proprietary model, integrating it with all the data pipeline elements, is what we have as part of your Vertex AI development. Now, all this is fine. So over here, you use existing models. You don't need data. You don't need modeling expertise. Over here, you need data. You don't need modeling expertise. Over here, you have the data and you will also need some modeling expertise. But all this will run on some infrastructure, right? And on our side, we provide varying sophistication of infrastructure for you to build your models. So if you have extremely complex models, like for example, BERT or T5, right? Or if you want to build those kind of transformer models, which are extremely heavy, we have something called TPUs that you can use to build models. Typically, these are models that have billions of parameters that need to be learned, and trainings would run into days, if not hours. if your model is not that complex, but still it is complex, especially if it is like image classification and so on, then you may want to use something like GPUs. We provide that also on our platform. And if it is fairly simple models, you can use CPUs. If you want to host your models, typically you would host it on CPUs as well. And from a framework perspective, we support all the popular frameworks, which include TensorFlow, Keras, PyTorch, Scikit-learn, PySpark. So this is a quick overview of how our AI/ML stack looks like. Now, if I start going into like details of each of those different blocks that we saw in our previous slide, right? So in terms of pre-trained APIs, 5 broad levels. So you have these basic speech to text, text to speech kind of APIs. If you want to include voice in your application, there are applications where you would want to like click the microphone icon, capture what the user is telling as an input instead of somebody wanting to type it. You can do that. You can then send that audio which you have captured on your device either in a streaming mode or in an async mode to the speech to text API. That gets converted into the text, and then you can use the text that you get back in your application for any downstream processing, right? It can be search, or it can be to ask the follow-on question, whatever it is. So all those APIs are available on Google Cloud. That is how you would integrate a speech to text or text to speech in your application. Cloud Vision is where, for example, you have an application, you want to take a picture of that application. So you have an application, in that application, you have integrated your camera. You want to take a picture, and then you want to send that picture or upload that picture to find out more information about the picture. Like, for example, is there a person in that picture? Is the person smiling? Or is there a popular destination or tourist place in that picture? Or is that picture representative of a product, right? Are there shoes or wheel cart or a truck or a car in that picture? So all that information can be obtained using Cloud Vision API. So in your app, you can integrate it with your camera, you can take an image, you can upload or send the image via an API call to Cloud Vision, and Cloud Vision will send you back a JSON response with all the descriptors that are present in the image. In your app, you can use those descriptors to take appropriate action in terms of what needs to be shown next for your user. So that's about Cloud Vision. Cloud Natural Language, again, has a wide variety of use cases. So you can send a text to this API, and then you can extract entities from that text, which would include dates that are mentioned in the text. It could include people that are mentioned in the text. It could include places that are mentioned in the text. So all those can be extracted automatically using entity recognition from Cloud Natural Language. You can find out sentiments of what is being spoken or what is being uttered in that text using Cloud Natural Language itself. And then you can also extend it to classify some of the text. We'll talk about that maybe a bit more in AutoML. Video intelligence, very similar to Cloud Vision, but applicable across frames in video intelligence. So over here, if you are able to identify an object from an image, over here, you will be able to identify objects that span across the frames of a video. You may also be able to identify some small actions, like if somebody is running or jogging or walking. All those kind of things can be extracted very easily using the Cloud Video Intelligence API. And then Translate API is to translate text from one language to other, and we support a wide variety of permutation combination of these languages. So these are all different APIs that are available, and you can weave them together. Like, for example, if you are building a voice bot, so you capture the voice using your microphone, you do a speech to text of that, you send that to Cloud Natural Language, you can do sentiment extraction, you can do entity extraction from that, and then it comes back to your application. And then you have some business rules in terms of if it is negative sentiment, give this response. If it is positive sentiment, give another response. And then that response can be passed to text to speech, and then the audio can be played back from your application. So all those kind of interweaving can happen across these APIs, right? So it can also be possible that somebody tells something in a vernacular language, you capture that, you translate that into English, then you can do some natural language extraction. Uh, you can then have some fixed response which can be translated back into some other vernacular language and then spoken out. So it's possible to kind of create fairly complex use cases by just these APIs itself. Now, I think we covered this chart earlier also in terms of where you would use when. So if you don't have any labeled data and if you don't want to write your own code, you would use pre-trained APIs. But now let's say uh, uh, you have your own data, right? So you do have training data, but you don't want to code yourself, in which case is where you will go down to the AutoML path. And this particular slide will keep coming multiple times in the subsequent sections as well. So yeah, let me admit. Yeah, sorry. Yeah, sorry. Yeah. So now let's take a look at AutoML and how it works, right? So what happens in AutoML is usually you would have a set of labeled images. In this case, if it's a retail scenario, you will have a set of images that indicate whether it is a handbag image, a shoe image, or a hat image, and you will have like hundreds or thousands of such images. You can upload those images onto the platform, and then Cloud AutoML can be trained to identify or build a model that identifies these objects or patterns, and then you can host it as an endpoint. In which case, then whenever you upload a new image, it can tell you whether that image is a shoe or a sandal or a hat, and it can have a wide variety, right? You would have trained it on one kind of shoe, but then if you upload a similar looking shoe also, AutoML is now able to classify the image correctly based on the data that it has been trained. And the same thing applies for text also. So you can have a lot of labeled text, and you can classify the text into like this. This is a news item about sport. This is a news item about lifestyle. This is a technology news article. And you can create your training data set in that form. You can build a model using this training data set. And after that, whenever you upload, for example, a new text, it will automatically start telling you whether the text is about sport, or whether the text is about technology, or whether the text is about travel, depending on what kind of use cases you have used for your training. So this is a quick example of how or what AutoML, or this is a very high level overview of what AutoML does, right? Now, what is the advantage, or where does it help, or what is the value of AutoML for you as a user or an app developer, right? Now, usually in a typical machine learning flow, what you would have is you would have collected your data. It is sitting in your data warehouse. And then as part of building a machine learning model, you would start preparing your data for machine learning, in which case you would have to like do a lot of operations in terms of if there are dates, you may have to split the dates. If there are a lot of uh, array or list based elements, then you would have to flatten them out into one single category. You may have to do some sort of one hot encoding if there are uh, different textual values, right? So you have to do a lot of these data preparation things as part of preparing your data for building the model. You will also have to, if it is text data, then do n-grams. You will have to encode your categories. You will have to create embeddings. And these are like fairly time consuming tasks, right? Typically in an ML engagement, what we say is data preparation is 90 to 95% of the effort that is needed to create a model. And that is that involves a lot of manual imagination, creativity, and it also needs a lot of compute power, and it also needs multiple iterations to get it right. Um, then once you have prepared your data, you would get into the model creation phase, which is where you would want to try out different algorithms. In those algorithms, you would want to try out different parameters. And then for each of those parameters, you would have to train the model for hours together. And it may happen that you will train like 10, 15, 20, 25 models, and then not one single model may be giving you the best result, but if you combine a few models, that will give you a good result. So you will go into ensembling of the models as well. So that's the whole model creation piece. And post that, once you have created your model, you will deploy the model and start using the models for prediction. So this is a fairly complex process, and a lot of things over here are standardized repeatable tasks. A lot of things over here also can be repeated, but both of these need scale, right? Especially if you're dealing with millions of records, especially if you're dealing with hundreds of models and model algorithms. So with AutoML, what we have tried to do is we have tried to abstract this whole piece of preparation of data and creation of models. And this platform takes care of all that for you in a fairly automated manner. All you need to do now is specify the budget in terms of how many hours do you want the platform to try for building out the models. 20 hours, 10 hours, 8 hours, 2 hours, depending on how much budget you want to spend. And then AutoML tries to explore a good model for that many number of hours, and it would host the model. Right? So that's how simple it is. So I see a few questions here. So how many languages are supported by natural language processing? On the API front, we support a lot of languages, about 10 to 12 popular Indian languages as well, but almost, I think there are quite a lot of languages, including European, Indian, and Southeast Asian languages. So from a NLP perspective, those are already supported. On an AutoML front, for classification, we support 20 languages. For entity recognition, I think there are still about, I think about 100 odd languages, which include popular Indian languages as well. So that is supported for entity extraction in AutoML. But for classification, it is about 20 odd languages. For sentiment analysis in AutoML also, it is about 20 odd languages. Is AutoML completely automatic, or have some scopes of feature engineering and parameter tuning? Uh, it is completely automated. All the feature engineering and parameter tuning is happening under the hood for you. So once you specify the training budget over here, anything, all this is under the hood for you. You don't have to do any work on that front. Is it possible to get information of the final trained model as output? Example, what model we have used, how many layers? Yes, it is possible for some types of model, especially if you're building a tabular data kind of model. It will tell you what model was used and what hyperparameters were used, what was the complexity, or how many layers are present in that. But that is available only for tabular data. And if it is an ensemble model, it will also tell you how many models in the ensemble were present as part of the AutoML model. So with that, let me move to the next slide. When we say that we have simplified this whole complex process, now you just need to enter the training budget, and all the hard work is done by the platform, then the question would be like, okay, how good is this model, right? So what we have been doing is we have been entering AutoML models into some of the Kaggle competitions. And what we have found is the models that were created by AutoML have been performing fairly well in quite a lot of these competitions, right? So they figure in some of the top 10% percentile as far as Kaggle scores are concerned. And these are just some of the competitions and the team sizes that were present in these competitions, right? So we have had a fairly, the slide essentially is to indicate that the AutoML models are not fairly trivial models, even though the effort involved is minimal. They are fairly complex models, and you get a good, decent performance for these models, right? So now let me just quickly give a quick demo of how it would look. Right. So if I go here, this is my Vertex console. I will try to zoom in a bit so that you can see. If I go here, there is something called data sets. If I want to create a new data set, I can go over here. I can select what kind of data set it is. So if it is an image data set, I can select image, and then these are the different types of ML problems that I can solve. So I can solve for image classification, single label, multiple label, object detection, object segmentation. If it is tabular data, I can solve for regression or classification. I can also solve for forecasting. If it is textual data that I have, the label data set, then I can solve it for classification, entity extraction, or sentiment analysis. I can also build AutoML models for video, in which case I can do action recognition, classification, object tracking, right? So these are the 4 different types of data that are supported for AutoML, and these are all the different problem types that can be addressed, right? Now, if I'll just go through an example of image classification. So if I say uh, select or create a data set for image, I can give like maybe a name, X-ray or pneumonia or whatever. And I won't go through this whole process because I have already kind of imported one, but this is how I would do it. I would say X-ray pneumonia data for image classification, click on create, and it will ask me where I want to or how I want to import the data. Let's just maybe go through that step as well. Yeah, so it will then prompt me to import the data. I can import it either from images on my computer or images from cloud data store. So there are these different options that I can select to upload the images, and I can do multiple levels of upload. Now I won't upload images as part of this demo, but what I will do is I already have a data set which I have uploaded. So you can go directly to that. So this is a pneumonia X-ray data set that I have. And this has about like 26,000 images. These are all the different images that were uploaded. So there is a label which is 0 or 1. So 1 indicates pneumonia, 0 indicates no pneumonia. And I have labels for each of these images, which I have uploaded as part of my data set, right? And this gives me a quick breakup of how many images have no pneumonia, how many images have pneumonia. If I want to like relabel, if I have wrongly labeled something, then I can go here. I can change the label from 1 to 0, 0 to 1. I can do all those things. But at the end of it, I will have a labeled data set, right? So there are 26,683 images. All of them are labeled, and this is the distribution of those images. Now, once I have done that, what do I do next? I can just go here, click on train a new model. The data set is automatically selected. The problem type I had selected when I was creating the data set. I can select the kind of model that I want to build. Since this is an AutoML demo, I can select AutoML. If I want to build a model that would run on, say, edge devices, I can also select AutoML Edge. And then I give the name of the model. I can select my training, validation, test data split. I can select if I want any explainability to be included. And then I just specify the budget. For image, it is 8, and for text and tabular data, I think it is 1 or 2 minimum. And then I just have to click start training. Once that is done, a model will start getting trained for the number of hours that I have specified. If a better model is found using less than these number of hours, it will automatically stop training, and I'll get an email saying model is ready for use if I have selected this. Otherwise, it will run for the full 8 hours. Okay. Now, once the model training is done, I will start seeing the model job is completed over here. And if I go down to the models tab, then I will see my model that is ready for consumption. This is the model registry of Vertex AI. I will just open a pre-trained model just to show you how it would look. So this is a model that has been trained on that data set. So you will see like uh, the model performance in this case. You will see what's my precision, what is my recall, what is my confidence threshold, what is the confusion matrix looking like. So looks like this model is performing okay. Uh, it's doing well for non-pneumonia images, but not so great for pneumonia kind of images, right? So that I can take a look at all those model performance metrics. I can see of the 26,000, how much was used for training, how much for validation, how much for test. And once that is done, once I am happy with the model, then what I can do is I can go over here and click on deploy to endpoint. Now, if I do this, then let's try that also. So I click on deploy to endpoint. I can give the endpoint name. So test underscore endpoint, for example. And then I can to continue. I can decide how many nodes should be available for this endpoint. So this will, so what we mean by an endpoint is you have trained a model now, which will take an X-ray image and which will tell you whether the X-ray image indicates a pneumonia or not, right? So that's the model that I have built. That model is offline as of now, right? You have trained the model, you have tested the model using some of the images that were present in the data set. But if it has to be consumed, and maybe if you want it to be integrated as part of your, say, mobile or some medical device, then it needs to be hosted, right? So the model, you should be able to call the model from any device, or you should be able to upload a set of images to the model and you should get the results back. Now, that is what we mean by an endpoint. So when I click on deploy to endpoint, what this platform does is it will take the model that you have trained and it will try to put it on some machine for you to consume. And depending on what kind of traffic you expect, you can decide the number of compute nodes you want to allocate to an endpoint. So for example, if it's a medical use case, it may not be too high if it is just for one specific hospital or one specific doctor that you are building. But if you are building it for like as a national healthcare service, where all the hospitals and all the doctors can start uploading images, in which case the traffic can be extremely high. So if it is for very simple small scale user, you can go with 1 or 2 or 5. If it is like for huge volumes, you can go with larger number of nodes also. And then you click on deploy, and that will result in an endpoint being created for you. Let's go to an endpoint example if I have one. So this is an endpoint, and you can now start sending requests to this endpoint in this particular format, right? So then you will start seeing the results of your model. You can also see the performance of the endpoint in terms of how many predictions per second it is making, how many requests per second it is handling, what's your latency, and accordingly you may want to add more resources or more compute nodes to this, right? So this is one full flow of how you can start with a labeled data set, how you can build a model, how you can check the performance or evaluate the performance of the model, and then how you can host it onto an endpoint, and how you can make calls to the endpoint, and how you can check the performance of the endpoint, right? So that was a quick overview of the AutoML. Now, the platform, the Vertex platform, other than AutoML, if you have the appetite for building something more complex, other than AutoML, this is what we saw just now. But other than AutoML also, there are a lot of features that are available as part of Vertex AI. So just a second. There is notebooks that is available for you to build your own code, custom code. You can host those models that you have built using notebooks onto prediction endpoints. If you want to build a model at scale and in a scheduled manner, continuously every month, every 15 days, or whenever data is available, and you want to scale it, you can use pipelines. You can use something called feature store to reduce the latency at which the predictions are happening, because then the prediction endpoints directly query for features using feature store, and your overall prediction time would reduce. You can monitor your model to see if there is any deterioration expected uh, as part of your model prediction. And you can also integrate explainable AI into the whole mix to find out why or which features are contributing towards a um, specific like for example, if you are predicting a churn, right, and you want to understand why a customer has high propensity to churn, you can use explainable AI, and it will tell you whether it is because his usage has decreased over the last 1 month, or whether because it is that he has recharged for a lesser amount, or he has not recharged at all. So all those features are expected to be part of the model, but explainable AI can tell you which feature influenced a specific prediction score. Right? So all these things are available as part of Vertex AI. So Vertex AI is not just AutoML, right? What we saw is just one demo of AutoML, but there are all these different capabilities that are available as part of Vertex AI. This is an example of explainable AI that is available as part of Vertex. So if you upload an image, or this is an example of a tabular data, what explainability will give you is uh, which pixels of the image resulted in classification of this image as a dog image, right? So bluer images, or outer or less critical images, are shown as not so important, whereas these sections are shown as important predictors in terms of get this image getting classified as a dog, right? So you will get this kind of a bitmap. In terms of tabular data, it will tell you attribution values, right? So it will tell you whether Euclidean distance contributed to a higher impact with regards to certain prediction in terms of this is a model that predicts, I think, mileage. And then it is telling you in terms of distance traveled, or in terms of starting destination, ending destination. I think it is dependent on traffic and so on, right? So here it will tell you each feature and how much of it has it contributed towards a specific prediction value. So that's about explainability. Feature store, I think we already covered. What I will also want to show you here is like we saw AutoML. If you want to do your own custom development, you can go to Workbench, and once you go to Workbench, you will be able to spin off your own notebooks. So these are all like Python Jupyter Lab notebooks. So you can spin off a notebook, a TensorFlow notebook, or a PyTorch notebook with GPU, without GPU. Let's say with GPU, you can specify the region. You can get all these things pre-installed in terms of CUDA libraries. You can select the operating system also. You can select the disk size. You will get an estimate in terms of how much will it be if you don't shut it down and leave it running for all throughout. And all those things, once it is complete, you will start seeing a notebook over here. If you click on Open Jupyter Lab, this is what you will see. This is a typical standard Jupyter Lab notebook. You can click over here, say Python notebook. It will open a blank notebook for you, and over here, then you can start writing your uh, uh, code, right? And yeah, it's fairly that simple, and you can write your TensorFlow code or whatever things you are importing, uh, and start building your model. So that is one quick demo of how the notebooks come. The other thing that I also wanted to show you was, let me see if that is available. I think it's just loading. There are two types of notebooks. That is what I wanted to show. One is user managed notebooks. This is something that you have to be careful about. You will have to manually go and shut it down or stop it. Otherwise, you will be charged for the notebooks that you are creating and for the time that it is running. If you have GPUs attached, it will be very expensive. When you are creating managed notebooks, it will automatically kind of do some amount of auto shutting down and things like that if you don't use the notebook for 60 minutes or so. So this is a slightly more advanced or managed version of the notebook, and gives you or it is more cost effective because it has some safety mechanisms built in, right? Now, it also has some built-in integrations with our sources like BigQuery or GCS bucket, PySpark, Dataproc, and all that. So it's fairly easy to build an end-to-end system using all of the GCP components if you're using managed notebooks. So I think we are close to 1 hour. Um, I will pause here to see if you have any questions.
Vipin, there are some questions in the chat section in case you want
Yeah,
to
those I
answer
have
those.
answered, Nilesh. Yeah, those I have
Okay.
already answered as and when they were posted.
Okay. So then I'll be opening the chat section. I'll be removing the mute icon, right? So when anyone have any question can ask directly with Vipin.
Okay, so while you are thinking of questions, if you have any, I'll go back to this chart once again um, to quickly summarize and maybe discuss about one more approach of AI ML on Google, right? So if you don't have your own data, if you don't have your own model, use pre-trained APIs and integrate AI into your application. If you have data but don't want to build your model, don't have data science experience, use AutoML. It will give you a fairly good model out of the box. If you have your data, if you want to build your own models, two options available here also. One is custom model, which we saw using Vertex notebooks. So you can build those custom models and host it. The other option is if you are very good at SQL, you can also build good machine learning models using BigQuery ML, in which case you will essentially write your queries in SQL itself, right? So this, if you look at the screen, this is just an example of how you can create a model using linear regression in this case, but it's a SQL statement. And then you can make predictions also using SQL statements in batch, right? So this is a fairly straightforward way. If you don't want to use Vertex, if you don't want to get into Python, if you don't know Python, but you are fairly strong on SQL, you can use BigQuery ML to build out your machine learning models inside of BigQuery itself. And they support almost all of the popular algorithms for classification. You can see it supports like logistic regression or deep neural networks. For regression also will support most of the popular models. You can also do uh, clustering or forecasting kind of problems as well on BigQuery. So this is yet another option that you will have if you are using GCP stack in terms of building out your ML models. So that's
Folks,
all.
please go ahead and go ahead. If you have any questions, you can ask. I have, you can now unmute yourself and ask the question in case you have any.
Doesn't look like. So if there are no questions, then I think I wish you all the best for your hackathon. And I hope you have a great time using some of the Google AI ML capabilities. And feel free to reach out to us in case you need any help or clarification with regards to how you can uh, build AI ML using GCP. I will maybe leave you with one very big picture view of the overall architecture in terms of an AI ML stack on Vertex. Uh, but yeah, otherwise, I think we are good.
Okay, thank you so much, Vipin. And thank you so much, folks, for attending this session. I'm sure this session will be useful for you to in maybe like build your idea or prototype in the hackathon. The video will be available as on demand. This session will be available as on demand video on the hackathon page. So just in case you want to refer to or you want to go back to what Vipin has told, you can definitely watch that on the hackathon page. So thank you so much once again for joining us in this session. Wait, there's another question. I'm like on the chat, Vipin, in case you want to answer that.
Is there any scope in MLOps for the future? I mean, I'm assuming you are asking about applications of MLOps going forward in the AI ML domain. Uh, so yeah, but let me know if that is not the right interpretation of the question. But yeah, from that perspective, yes, MLOps is a very integral part of uh, the whole AI ML development. One of the main reasons why AI ML engagements were not making it to production was because there was no streamlined or standardized methods to operationalize machine learning. But with MLOps, now we are coming up with a lot of processes, procedures, tools, and techniques to make sure that uh, the whole machine learning process is now repeatable, scalable, and deployable. And also, we have the ability to monitor. So yes, that will be a very important aspect of machine learning, especially whenever you have to build ML and take it to production. I hope that answers the question.
Great. Thanks. I mean, like just a last shout out in case any of you have any question, feel free to ask because we still have a couple of minutes there.
Yes, myself, Anil. Like actually, the previous question was asked by me. Like, and I was been in the DevOps since 6 months, and I'm just as interested in the machine learning and AI. So, so how could be the like ML ops would be benefit? Like, and I have chosen the DevOps, so it could be a adding of security features to DevOps. So, so what could be the better? Like an ML ops would be the way is better, or than DevOps will be the way the better. Like an ML, like an it's an I think a pretty complex. We can see.
Yeah, yeah. So Neil, great question. So DevOps and MLOps, though the intent of or the end objective is the same in terms of moving things to production in a much more predictable and quicker way, there are subtle differences because of the uh, differences with regards to the development itself, right? For software development, it's a different process. Things are very predictable. Um you follow certain software development approaches, and you build out a software which you can move to production as you are building it out after going or after putting it through some sort of test cases and automated testing. Whereas in case of machine learning, the process is slightly different, whereby uh, there is a huge dependence on data. The code that you are writing is not what goes into production, but the code that you are writing is essentially trying to find out patterns in the data. And those patterns is what gets moved to production, right? So there is a lot of experimentation that is going to happen. And also the scale is a bit different in terms of you may have to deal with a lot of image data, you may have to deal with a lot of audio data. Sometimes in some cases it is just plain tabular data. So in those cases the whole way the development takes place and the way it moves into production is slightly different from a classical software development process. And that is why this whole field of ML ops has developed in parallel to DevOps. Right? So, yeah, I hope that answers your question. There is also one question from Aman. What is the requirement for data scientists? So I am assuming what you mean is what are some of the skill sets that are required from a data science perspective? So yeah, a good amount of uh, software development skill with regards to expertise on some of the popular frameworks. It's a good sound mathematics foundation, and statistics foundation to some extent. And nowadays, if you look at the system architecture, some good amount of system knowledge is also required, especially if you are talking about ML at scale.
Great. Thanks, Vipin. I hope, Aman, that answers your question. Uh, so, anyways, I think we are. I'm like, let's wrap up this session now. So again, thank you so much, folks, for attending the session, and I'm sure it was quite useful. And obviously, will be in coming days with respect to the hackathon that we are doing in collaboration with Hacker Earth. So stay tuned for more for more upcoming sessions, and obviously these sessions will be available on the hackathon page as an on-demand video, so you can refer back anytime. Thank you once again. Thank you, Vipin, for your time. I think it was very insightful, and hope it was great interacting with the folks around here. Thank you, and hope everyone has a great day ahead. Thank you so much.
Thank you.